Hey, for Izora. Okay, now we are going to continue with our topic that is 2.9 forces in equilibrium. Okay, from our previous class, we have learned about additions of vector. So we have learned about the parallelogram rule, parallelogram method, and the tip to tail triangle method. So we have learned these two things, but we didn't manage to cover resolutions of force and three forces in equilibrium. Okay, so I make this video just for you guys so that we can like cover up these two topics, which is the resolutions of force and three forces in equilibrium. Okay, are we good to go? Okay, let's go to. So now we're going to cover the resolutions of forces, or in the BM term, it is called as leraian daya. Okay, what is resolutions of forces? Okay, let's say there is a force acting. There's a force acted in such a way it goes from here to here. So this is the starting point. Here is the starting point of the force. So it goes from here to here. So how we want to resolve a force? Okay, every force, it has two components, component X and component Y. So if we want to resolve this force into those two components, so the X component is this way, X component. Okay, this is F, force F, component X. This is known as force component X because it's acting in the horizontal manner, which is from here to here. Okay, which is the melintang. Okay, that one is Fx. Okay, how about Fy? So Fy, it goes straight, upright. So it goes upright. So let's say we use green color. Okay, so this one goes upright. So this one is Fy. So this is what is known as resolutions of vector, resolutions of force. We can like break this force into two components, that is Fy and Fx. Okay, if we make it into a detailed diagram, actually we can form a closed right angle triangle. How? Okay, kita boleh bentukkan satu segitiga yang tertutup. Okay, just now this one is force F, so force F component X, it goes from here to here, Fx, and then after that it goes upright. So for F component, X component, it goes from here to here. So Y, for F component, Fy component, it goes from here to here. Fy. So here you have it, a closed right angle triangle. Why is it right angle triangle? Because you can form a 90-degree triangle. Okay, so this is resolution of force. Okay, for every time you resolve a force, you will get a angle. So let's say from here you get angle theta. Same goes here, angle theta. Okay, so why is it so important that we need to learn about resolutions of forces? Okay, the important is we can find the magnitude of F. Okay, find the magnitude of Fx and Fy. That's the first thing. And the second thing is we can find the magnitude of angle theta. Okay, so how we want to find the magnitude of Fx? Okay, how we want to find Fx? Okay, so we go back to basic trigonometry. Okay, what is cos theta? Okay, cos theta. Okay, cos theta is equivalent to adjacent over hypotenuse. CA Okay, that's how you guys that's the way how you guys remember, right? Okay, so in this case, what is the adjacent? Okay, you see, okay, here is the angle, here is angle theta, here's angle theta. So which side that is adjacent to angle theta? In this case is Fx. So Fx. So Fx is the adjacent side. Okay, hypotenuse. So which one is the hypotenuse? So hypotenuse is the side that is opposite the right angle triangle. So this is the right angle triangle, and opposite the right angle triangle is F. So this is the hypotenuse, F. Okay, so now we want to rearrange this formula so that we can find the magnitude of Fx. So how is that? Okay, so we bring F to the other side. So we bring F to the other side, so you will get F cos theta equals to Fx. So there you have it. So you have this formula. So Fx is equals to F cos theta. Now, the next thing that we want to find is the value of Fy. So how we want to find Fy? So we going back to trigonometry, basic trigonometry. Sine theta So what is sine theta? Sine theta is opposite over hypotenuse. SOH. So in this case, which side is the opposite? Okay, this is the angle theta. So opposite angle theta is Fy. Fy. Fy over hypotenuse. So in this case, hypotenuse is the side that is opposite the right angle. This is the right angle, so opposite right angle is F. So now we want to rearrange this whole formula to get Fy. So you bring F to the other side, so you will get F sine theta is equals to Fy. So here you go. F sine theta is equal to Fy. So this is resolutions of force. From today's lesson, we have learned about resolutions of force. So from resolutions of force, we can find the Fx, the magnitude of Fx, which is Fx is equals to F cos theta. Whereas for Fy, the value of Fy is equals to F sine theta. Okay. Now we have learned about resolutions of force. Now we are going to do the example. Okay. Please refer to the worksheets that I have distributed to each and every one of you. See example 3. Okay, the lawnmower is pushed with a force of 120 Newton by a gardener at an angle of 30 degrees with the ground as shown below. Okay, in this case, okay, here's the lawnmower, here's the gardener, and the gardener pushed the lawnmower at an angle of 30 degrees, and he exert a force of 120 Newton. Okay, find A, the effective force that enabled the lawnmower to move forward, and B, the effective force that assists in pressing the lawnmower to the ground. Okay, so for this kind of question, the first thing you need to do is you need to resolve the force. Okay, you need to resolve the force. Okay, let's see. Okay, we take this part over here. Okay, here is 30 degrees. Okay, and then this force is heading this way, 120 Newton. Okay, now we want to resolve this force. Okay, first thing you need to see is that where is the starting point of this force? The starting point is here, right? Okay, so means that you need to resolve from here, this point. So where is the x component? So the x component is here. It goes horizontally. So this is fx. How about fy? Where fy goes? Okay, fy is acting vertically. So in this case, this force is going downward, right? So fy is going down. So fy. Okay. From here, actually, you can form a close right angle triangle. How? Okay. If you see here, actually, you can form a close right angle triangle. Just that all you need to do left is move. Instead of doing the x component here, you bring this this x component down here. So you will get a diagram like this. So this is the fy, fx. So this one is the 120 degree, 120 Newton. So the angle is over here. So this is 30 degree. And this is 90 degree. So you have found a right angle triangle. So the next thing you need to do, so you have done step 1, resolve the force. So step 2, you need to find value of fx and fy. So what is the value of fx and fy? Okay, we see here fx. Okay, how we want to find fx? Fx is, okay, before that, what is cos? Cos theta. Okay, theta in this case is 30 degree. So cos 30 degree. Cos 30 degree is, okay, cos is adjacent. Okay, in this case, adjacent, the adjacent side is fx. Fx over the hypotenuse. Hypotenuse is opposite the right angle. In this case is 120. 120 Newton. So now all is left to do is to rearrange this equation so that we can find the value of fx. So we move 120 Newton to the other side. So you will get 120 Newton times cos 30 degree. So you will get fx. Therefore, fx is fx is 120 times cos 30 degree. So you will get 103.9 Newton. So that is the value of fx. Okay, now how about fy? So fy, sine 30 degree. Okay, sine is opposite over hypotenuse. So in this case, what is the opposite side? So opposite side is fy. Fy over hypotenuse. Hypotenuse is 120 degree. 120 Newton, sorry. Okay, 120 Newton. So how to find the value of fy? You need to bring this 120 Newton to the other side, so you will get 120 Newton times sine 30 degree equals to Fy. So what is the value of Fy? Fy. So 120 times sine 30 degree. What you can do is you can pause the video and then you try to do the calculation on your own. Please, I want all of you to practice. So please don't rely too much on this. Don't rely too much on the answers that I give. Please, you need to have your own effort to do the calculation, okay? So that you can practice. Okay, so 120 Newton times sine 30 degree is 60 Newton. Okay, now let's get back to the question. Okay, A is find the effective force that enables the lawnmower to move forward. Okay, the keyword here is enables the lawnmower to move forward. Enables the lawnmower to move forward. Okay, if we see here how the lawnmower, if the gardener push the lawnmower like this, so where is the lawnmower going to move? Of course it's going to move to the front, right? So it moves to the right. So which component that act in the same direction? Which one do you think? Of course it's Fx. So the answer for question A is Fx is equals to 103.9 Newton. So that is the answer. So Fx is the effective force that enables the lawnmower to move forward. In this case, the answer is 103.9 Newton. Okay, now B. Find the effective force that assists in pressing the lawnmower to the ground. Okay, the keyword here is assist in pressing the lawnmower to the ground. So, which force that push the lawnmower to the ground? Press the lawnmower to the ground. In this case is Fy. So, what's the value of Fy? So the value of Fy is the effective force that enables the assist in pressing the lawnmower to the ground is 60 Newton. Okay, 60 Newton. So there's your answer. So that is for question number question 3, example 3. So now we proceed to example 4. Okay, example 4. Example 4. A 30 kilogram box slides down a slope inclined at 30 degrees to the horizontal as shown below. What is the component of the weight that enables the box to slide down the slope? And B, what is the acceleration of the box down the slope if the friction is 30 Newton, given that gravitational acceleration is 10 gram meter per second square. Okay, you can pause the video and try to do it on your own. If you done with your work, so you can replay the video and check your answer. Okay, welcome back. Now I hope that you have done your steps. Okay, so let's do this question. Okay, A, what is the component of the weight that enables the box to slide down the slope? Okay, before we go through the question, once again, we do step by step. First thing you need to do is you need to resolve the force. Okay. What is the force involved in this question? In this case is weight. Okay, but where is the weight act on the box? Where's the direction? Okay, here's the box, so the weight is always go downward, straight downward. So weight is like this. So this is weight. Now you need to resolve this force. You need to resolve weight. Okay, how? First thing first, you need to find the x and the y component. Okay, first you need to find the x component. So x component is the x component of this x component of weight is this way. So this is Wx. Okay, how about component y? Component y is this way. Okay, so the angle is over here. So here is 30 degree. So you have resolved the force. Force in this case is the weight. So let's get back to question A. What is the component of the weight that enables the box to slide down the slope? Okay, the keyword here is slide down the slope. So between Wx and Wy, which component that enables the box to slide down the slope? Slide down the slope. Wx. So we need to find the value of Wx. Okay, solution A. So Wx is W sine 30. Okay, probably some of you confused how to get this. Okay, before we get into details, let's see how we get this. Okay, you get after you resolve W, you will get this, right? Okay, let's form a close right angle triangle. Okay. So wx x component always act horizontally. So this is horizontal wx, and then wy is always act vertically. So wy, so all is left is w. So this is w, and then angle 30 degree. Angle 30 degree is between w and y. Okay, you see here, w and y. 30 degree is in between w and y. So 30 degree is over here, and this is right angle. So sine 30 degree is opposite over hypotenuse. In this case, the opposite is wx over hypotenuse. Hypotenuse is the side that opposite right angle is w. So w. So you rearrange this, so you will get wx is equals to w sine 30 degree. Go to the other side. So that's why you get this. So okay, w, weight is equals to mg. So mg sine 30 degree. So what is m? Mass. What is the mass of the box? The questions given is 30 kilogram. So 30 kilogram. What is g? The questions given, g is 10 meter per second square. So 10 sine 30 degree. So you will get 30 times 10. Okay, so you get 300 times sine 30. So you will get 300 times sine 30. So you get 150 Newton. So that is question A. Okay, question B. What is the acceleration of the box down the slope if the friction is 30 Newton? Okay. We'll see the diagram again. Okay, in this case, the box is in contact with the surface of the slope, right? So where is the friction? Where is the direction of friction? The direction of friction is this way. F friction. Okay. So what is the acceleration of the box down the slope? Okay. So it all back to the addition of vector. In this case is between F friction and Wx. So B. So how to find the acceleration? First, you need to add these two factors together. How? F net, or the resultant force. Resultant force, what is the formula of resultant force? F net. F net is equals to MA. So F net is the addition between the addition of the friction force, the friction, and Wx. Okay, so it equals to let's say this direction, going down the slope is positive. So positive Wx plus minus plus negative F friction is equals to MA. Okay, what's the value of Wx? Wx is 150. 100 and positive 150 Newton plus minus, you will get minus. Okay, friction, the value of friction is 30 Newton. So 30 Newton is equals to, what's the mass of the box? The mass of the box is 30 kilogram. So 30 kilogram times the acceleration. Okay, the questions wants to find the acceleration. So we need to find A. What is the value of A? Okay, so 150 minus 30, we will get 120 Newton is equals to 30A. Now 30 you bring to the other side, so you will get 120 over 120 over 30. You will get A. So the acceleration is A is equals to 4 meter per second square. Okay, so that is example 4. Okay, so that's all for resolutions of force. Please do more exercise on this, because this kind of question is quite famous in exam, especially SPM. So please do more practice on this. It may look complicated, but if you do more practice and if you're able to understand the concept, everything will be easy for you. Okay, so we're done with resolutions of force. Now we proceed to the next topic, that is forces, 3 forces in equilibrium. Okay, 3 forces in equilibrium. Okay, 3 forces in equilibrium. So imagine, okay, let's say there is an object O, object at point O, and then there are 3 forces acting on this object. Let's say force number 1, okay, this is force 1, let's say this force is Q. Okay, next force, let's say the second force is acting this way. So this is P, force P. Okay, next the third force is acting this way. Let's say this is force R. So we have three forces acting on this object O. Okay, my question to you is, are these forces in equilibrium? Well, it's already stated here, three forces in equilibrium. Okay, these three forces are in equilibrium. How do we want to know whether these forces are in equilibrium? Okay, the method that we can use to find out whether these forces are in equilibrium or not is to form a closed triangle. Okay, now let's combine all these three forces together to form a closed triangle. Okay, let's start with force P. Okay, this is force P, right? Okay, force P. Next, okay, let's say we do force Q. Force Q is acting vertically, right? Okay, force Q. Okay, force Q. And then next is R. R is heading this way. Okay, now let's see. The next thing we need to look is the direction of the force. Okay, let's say we start from force P. Okay, force P goes from here to here, right? And then force Q, it goes from here to here. And then force R, it goes from here to here. So if you see if we follow the direction of the arrow, it will form a closed triangle. It moves in one direction. Okay, imagine, let's say there is three forces. Okay, let's say, okay, just now this is in equilibrium. Okay, let's say this is object O. Okay, let's say force, this is force X. Okay, force X is going downward. And then let's see next force, this one is force Y. Force Y is going this way, the same like force R. And then last but not least is force, let's say this is force Z. Force Z is going this way. Z. Okay, now we want to combine all these three forces to form a closed triangle. Okay, this one is force Z, and then next is force X. It goes like vertical, and then next force is force Y. Okay, is this forces are in equilibrium or not? What do you think? It is not in equilibrium. Why? This is because that if we follow the direction of the force, it doesn't move in one direction. Let's say from force Y, it moves from here to here, and then from for force Z, it moves from here to here. So this one already shows one direction. However, from X, force X, it moves from up, and it goes down. So this one shows another direction. So there are two directions involved here. Direction 1 and then direction 2. They are not moving in one direction. So if there are more than one direction, means that it is not in equilibrium. Okay. So let's get back here. In equilibrium, what does it mean by an object in equilibrium? Okay, if it's in equilibrium, it means that the object is at rest. Means that the object is at rest if it moves in one direction. For this one, if it's not equilibrium, means that the object is not at rest. Okay. So that is for the subtopic 3 forces in equilibrium. So these are the things that you need to know about this subtopic. So now we discuss question number example number 5. Okay, so refer to your worksheets. See question number 5, example number 5. Okay, a 20 kilogram mass ceiling is pulled aside by a horizontal string until the supporting string makes an angle of 30 degrees with the vertical as shown below. Okay, there are two things that we need to find here. A, find the tension T in the supporting string. And the second question, B, find the force F exerted on horizontal string, given that G is equals to 10 meter per second square. Okay, now, so the first thing that we need to do is to form the closed triangle. Okay, solution. A. Okay, where is the point? Okay, the center point is here, here. So point. So going downward is W, the weight. Going to the right is F, and going this way is the tension. And then given that, so this is 30 degree. Okay, now we want to form a closed triangle. So going down is W. Going to the left is F, and then going this way is the tension. So the angle is 30 degree. Okay, first of all, is this in equilibrium? Okay, we see the direction of the force. The weight goes down, and then F is going from here to here, and then the tension goes from here to here. So they are moved in one direction, right? So they are in equilibrium. Okay, now question A, say find the tension T in the supporting string. Okay, this is a right angle triangle. So we have 30 degree, and then we have the information about the weight. Okay, weight is equals to mg, right? Okay, so what formula that we can use? Cos or sine? In this case, we need to use cos. So cos 30 degree is equals to adjacent over hypotenuse. In this case, the adjacent is W, the weight, over hypotenuse. Hypotenuse is the side that is opposite the right angle, so it's T. So weight is equals to W is equals to mg over T. So what is the weight of the mass? Okay, mass, the weight of the mass suspended. So the mass is 20 kilogram. The gravitational acceleration is 10. Given is 10 over T, cos 30 degree. So how we want to find T? All you need to do is to bring T to the other side, and then this one you bring here. So you will get T is equals to 20 times 10 over cos 30 degree. So T is equals to 20 times 10 over cos 30. So what do you get? Okay, you will get 230.9 Newton. So that is the answer for question A. So next question B. Find the force F exerted on the horizontal string. Okay, F is this. So just now we already formed a closed triangle, right? Closed triangle. So now to find F, okay, what do you think? What method that we can use to find F? We can use the Pythagoras theorem. Okay, so B, okay, this one is F, this one is T. T is equals to 230.9 Newton, whereas for weight is equals to 20 times 10 is 200 Newton. So Pythagoras theorem, to find Pythagoras theorem is, okay, in this case the hypotenuse is T, right? So T square is equals to W square plus F square. And then we need to find F, right? So we need to rearrange this. We need to rearrange this to get F. So after you rearrange, you will get F is equals to T square minus W square root the whole thing. So F is equals to square root of T, the tension is 230.9 square minus the weight. The weight is 200 Newton. So F is, okay, please calculate. You can pause the video and do the calculation on your own. So what did you get? So F is equal to 115.4 Newton. Okay, so that is for question. So that is for example 5. Okay, now let's go to question example, the last example, that is example 6. Okay, example 6. Okay, example 6. Okay, example 6, actually it's pretty much the same, almost the same like the example number 5. So I want you to do it on your own. So if you're able to find the answer, please PM me your steps, your how you able to get the answer, then I will check it for you. So for for A, the answer is theta is equals to 30.96 degree. Okay, for A, the theta is equals to 30.96 degree. Okay, whereas for B, the tension in the supporting string T is equals to 29.2 Newton. Okay, so please do it on your own, and if you're able to find the answer, you can WhatsApp me, and I believe you all have my number, so you can like give me your answer. Okay, so that's all for today. So what have you learned today, class? So you have learned about the resolutions of force, and you also have learned about the three forces in equilibrium. So let's make a brief a summary of what you have learned today. Okay, the resolutions of force. The resolutions of force is, so this is the way how you resolve a force. So given that if a force given a force F, so you can resolve this force F into its component, that is the component X and then the component Y, and then from this component you can combine them to form a closed right angle triangle, and then from this you can get the you can find the angle theta, and then you can use this formula to find the value of fx and fy using the basic trigonometry rule, cos theta sine theta. Okay, that is for resolutions of force. Okay, the second thing that you have learned today is three forces in equilibrium. Okay, given that if there are three forces acting on object O, let's say for this one, Q going this way, P is going this way, R is going this way, then we combine all these three forces to form a closed triangle. If the direction of the triangle is moving in one direction, like R going this way, P is going this way, Q is going this way, so means that the object is in equilibrium. If the object is in equilibrium, means that it is at rest. If the questions if you read the question carefully, if you're able to find a statement says that the object is at rest, or the object is in equilibrium, or the object is static, or whatever terms that it use that give the same meaning, so means that they are in equilibrium. And then another situation is that if the forces are given like this, X, Y, and Z, and then you combine all these three forces to form a triangle, and then if the object is moving in more than one direction, like this one, Y is going this way, Z is going this way, however X is going this way, so there are two directions here, so means that the object is not in equilibrium. If the object is not in equilibrium, means that the object is not at rest, or not stable, or they are not stable. Okay, for this one, there if the object is in equilibrium, means that it is at rest, or it is stable. Okay, so that's all for today's lesson. Thank you and have a great day ahead.